Whoa, I feel clean. I knew that I would now. I feel clean. That's so feeling clean now. So clean, so clean. Lying fat, feeling clean. Hey all, this is Dustin, and that's right, we are making soap. Oh, buddy. And who doesn't like soap? I mean, come on, soap is great. Okay, so maybe Ralphie doesn't like soap, having it stuck in his mouth. I can understand that. But other than that, it's pretty cool. Students really get into it. They love the fact that they got to make something, and I let them take it home. Maybe that's not kosher, but hey, it's good with me. But, you know, we are using sodium hydroxide, and that's a pretty caustic chemical. It's pretty dangerous, and so you got to be careful. You know, might cause a little bit of damage.
What is this?
This is a chemical burn. It will hurt more than you've ever been burned, and you will have a scar.
What are you doing? So be careful. Make sure that you're treating that sodium hydroxide with respect. Right? Always treat it with respect. Anyways, we'll talk about more of that later. But for now, let's talk about what it is that we're going to learn about. So there's a couple big topics in this one. The first one is substances, mixtures, and properties. That will be the first big concept that students are looking at. What do those three terms really mean, and how do we use them in the context of the questions? How can I make new stuff from old stuff? And then we'll be looking at three particular properties, or we'll spend a lot of time on solubility, melting point, and density. Students will be measuring that, recording that. And then we'll also spend a lot of time looking at chemical reactions. And so what does that mean in respect to substances, mixtures, and properties? How does all that relate? How does solubility, melting point, density, how does that help me to tell whether or not a chemical reaction actually occurred? A little bit of review of particle nature of matter as we look at the fact that chemical reactions are indications that the atoms have rearranged in the molecules, and there's some modeling that goes around that. But in terms of scientific reasoning, that is definitely the biggest practice that will be worked on in this unit. They'll be doing a lot of claim evidence and reasoning using substances, mixtures, properties, that solubility, that melting point, density, those things that they have measured and have recorded data on. They're going to use that in order to show and provide evidence that they really did create a new substance. So then in terms of the learning sets, learning set 1 is how is this stuff the same and different, and in that one you're going to be comparing soap and fat. Those two will be your main comparators for the whole unit, and they'll be really kind of a focal point. You'll go off into other chemicals, but those will be the focal points, and you'll spend a lot of time at the first in learning set 1 doing all those property measurements. So really figuring out, well, what is the melting point difference between soap and fat? What is the solubility difference between fat and soap? The density difference, hardness, color, all those things that help us to indicate whether we have two different substances or not. And at the end, you'll do a claim, evidence, and reasoning about that question. Is fat different than soap? And they have to prove using their data that they collected, in fact, there's so many properties that are different. Yes, it's definitely a different substance. In learning set 2, how can I make new substances? It's really focused on the chemical reaction side of things. So we'll be getting the gumdrops out and rearranging atoms and be looking for those property changes and using that as a way to indicate, say, did we have a property change? Yes, we did. Therefore, we have new substances. In learning set 3, we will do it's a quick learning set. Do new substances always come from old substances? It actually has nothing to do with that. We'll be looking at how conservation of mass, that'll be a big one. And then we'll do most of it is about did we make a new substance? When we made soap at the end of learning set 2, did we make a new substance? And how do we know if it's soap? And proving that and doing the claim, evidence, and reason for that. And ending with a very short little engineering design thing. How do you improve your soap? All right, let's look at each learning set in more depth, starting with learning set 1. All right, learning set number 1. How is this stuff the same and different? So this is lessons 1 through 5 will be for learning set 1. In lesson 1, what you'll be doing is 1.1 is the introductory activity. This is where you really are not saying anything to students at all. You're just giving them these materials, copper chloride and aluminum, and you're having them describe the substances before, and you're trying not to use the terms yet. You're not using words like properties or substances or any of those things. You're just letting them make observations. So what does it look like before? What does aluminum foil look like? What does the copper chloride look like? They put the aluminum foil on the copper chloride, and there is a chemical reaction, but you don't say that there's a chemical reaction. You're asking them what's happening, what's going on. Describe the changes that you see. What does the aluminum foil look like after? What does the copper chloride look like after? And many of the properties change, including color and all kinds of stuff. So it's not, the important thing about that particular lesson is lesson 1.1 is you are not describing properties. You're not describing the chemical reaction, not even saying chemical reaction. You're just letting them experience this phenomena, and then we can come back to it and talk about it as we go through the unit as this kind of anchoring activity. And lesson 1.2 is when you introduce soap and fat, but start off with mystery material. So substance 1, substance 2, and don't tell them what it is, and make sure that they understand it's not about naming what it is, but describing what it is. What are the different characteristics of it? So have the students go through and list out different ones. Then you'll spend time after that in a discussion format to figure out, well, which of the descriptions are consistent no matter how big the sample is. So, for example, somebody might say the substance on the left is squishy and the substance on the right is hard. Okay, if we had more of the substance on the left, would that change its squishiness? No, it wouldn't. If we had more of the substance on the right, would it change its hardness? No, it wouldn't. But if somebody said substance on the left is heavier than the substance on the right, then you would say, well, would that change? And yes, it does. So then we get into this conversation about properties, and properties are things that don't change no matter how big the sample size is. And that is really important because it comes back over and over and over and over again. Then once we've talked about properties, now we can talk about substances and how a substance has the same properties all the time. So this soap, for example, eventually you're going to name these soap and fat, and soap, a particular type of soap, will have the same properties all the time. A fat, the same kind of fat, will always have the same properties no matter what. And so whether the sample size or any of those things. So properties help define a substance. And if you have different properties, then you probably have a different substance. And then we'll use those two terms then a lot over the next, for the rest of the unit, really. In lesson 2.1, then you start looking at some other properties that they did not discuss in the first lesson, lesson 1.1. The first one being solubility. Again, you don't use the word solubility to begin with. You talk about dissolving, or a word that they're used to, and then talk about, and you do a little demo in 2.1 to show about butter. So you have a piece of butter in oil and a piece of butter in water. Does it dissolve? What does that mean to dissolve? How do you know if it has? Is it cut and dry? Yes, it's dissolved. No, it's not dissolved. Or is there in-betweens? Can you have something that's partially soluble? Or is it something that's mostly soluble but not totally soluble? In lesson 2.2, the students then test the solubility of fat and soap, of the two substances that we're working with. So even though we're using very similar substances in 2.1, we're letting them test, record data for the actual substance, fat and soap. All right, in lesson 3, now we're going to be looking at melting point. And melting point can be a tricky one to determine exactly what the melting point is. And you can have as much conversation about that as you want. The key thing is that when you melt fat, it is much, much, much lower than soap, the melting point. And so students will have a hard time determining exactly what temperature it is. But as long as they get in the range then you're in good shape. What you'll see, though, is that the soap never melts. I mean, you can get up to 100 degrees Celsius boiling of water, and it won't melt the soap. And that's important. So the students will get frustrated. They'll be like, we're waiting, it's not melting. So we can tell the students then, well, what does that mean about the melting point of soap? And what I always say is that it just means that the melting point of soap is over 100 degrees Celsius. And so then we know for sure that the melting points are very different between fat and soap. In lesson 4, we will be looking at density. This is something that they have looked at in 6th grade if you've done the 6th grade units. Otherwise, you may need to talk about it more. And how do you calculate density? How do you calculate the volume of an irregular object? But then we'll be using density of fat and soap to figure out the another property. And then we wrap it up in lesson 5 with a claim, evidence, and reasoning for our fat and soap different substances. That's our question. So basically you go through and all the data that we collected so far, the color, the hardness, the solubility, the melting point, the density, and you may have collected other data as well, other types of properties that you as a class have decided upon. And things like slippery or slimy or greasy or whatever, then you can use those as well if you want to. But the students then create a big claim, evidence, and reasoning for that question, are fat and soap different substances? In learning set 2, you'll be looking at how can I make new substances. It's basically all about chemical reactions. So you start this one off with a nice reaction here with baking soda and road salt and water, and you put those together and they create a nice little change, and you get some gas produced and some temperature change and things like that. So you're asking students what's happening, and again, you're not talking about this as a chemical reaction. You're asking what happens to properties when you combine those substances. And so at the end, the idea is to come up with the idea that a chemical reaction is what happens, is what you call it, when you make a new substance. And we're looking again, we're going to go kind of back to that 1 through 5, lesson 1 through 5. How do we know we made a new substance? Well, we made a new substance because we had a property change, and that's the key piece. If you want to, it's actually pretty nice. You can do this as a demo to start with, or you can have students do it. You can have them test the solubility of baking soda. You can have them test the solubility of road salt. They'll find both are very soluble. When you do the reaction, the material that is produced afterwards is insoluble. It'll precipitate out, and so you can use that as an example of a major property change. You also had gas created that was trapped in there. If you leave one of the bags unopened and just leave the gas in there, you'll see the gas does not go back into solution. It'll stay in there, assuming you've got a good tight bag. But so that helps to show that the properties really did change. And that's lesson 6. In lesson 7, you'll burn some magnesium, which they love to do. And you'll, again, look at those substances. So magnesium, in terms of being its properties, it's got a certain color, it's got a certain hardness, and then afterwards, the material that's left over is a white powder and very different hardness. It's got different solubility, all kinds of things. So it's a great one for them to see those properties change. Okay, yes, we have a chemical reaction because the properties changed. Then in lesson 7, you have the students go through and do some modeling with gumdrops, marshmallows, whatever you've got, to show how those atoms are rearranging. And that was discussed in 6th grade. And it's coming back now to show that in a chemical reaction, really you're rearranging the atoms in the molecules. And you even introduced a little chemical equation in there. In lesson 8, you'll talk about acid rain, and as just another example of what you can do. In lesson 8.1, 8.2, they'll set up a little acid rain environment. You talk about Statue of Liberty and all that. You'll put some copper into a piece of clay. The liquid inside of that little tray down here is vinegar. And so you'll use that. You'll put a cup over top of it. This is a little plastic cup to create an environment that's got a lot of acid in the air. And then when you come back, of course, the copper has turned, or at least has, some little green powder all over it. And what students will find is that that's very soluble in water, and it's a color change and a hardness change. It's no longer a metal. So they get to see that, again, we made a new substance. We know we made a new substance because properties changed. It's really reinforcing that idea that a chemical reaction is anytime we have property changes, which means we made a new substance. Then they go through and do a much more complicated model of a molecule with the copper acetate. It's much bigger. Acetic acid and copper come together to make copper acetate, and the molecule is much bigger, but they can see that it still has that rearranging of the atoms going on. And then in lesson 9, they will do an electrolysis lab where they take just regular water, and I always have them put the water in from the tap. If your water is not too hard, this works great. And to speed up the reaction, you can put a little bit of, I think the notes say to put in some acid. That helps to speed up the reaction. But you then run electricity through it and create oxygen and hydrogen gas, which you can then burn off. And it looks like the water's boiling, so there's a good conversation there to be had about what's the difference between boiling and a chemical reaction. So is this a new substance when we just do this electrolysis lab? Then we talk about mixtures, and mixtures probably have come up somewhere along this. What happens if you have soap but it's got a color in it? And so this is where we really deal with that in head on, where students will mix together Kool-Aid into water. And the question is, well, we have a color change. We have the substance went from a powder to a liquid, so it looks like a chemical reaction. But then you have them boil off the Kool-Aid and boil off the water, and they can see that the powder is still there. Now, I'll be honest with you, this one's tough to pull off accurately. I seem to burn the Kool-Aid far more often than I actually get any kind of powder back. So it's a tricky one to pull off well. So be careful with it. I kind of like this idea of a spoon and a candle to see if we might control the heat a little bit better. I'm going to give that one a shot too. And then in lesson 11, this is where we make soap from fat and sodium hydroxide. And we use lye. I use a different method than in the book. The book does what they call a hot process method, where you're heating up the liquid and you're putting things in. I did that the first year, and I didn't like the quality of the soap, and I also didn't like I had students who were having a difficult time keeping the temperature at the right level, and so I had a few that started to boil, and then I had sodium hydroxide flying, and it just didn't make me feel comfortable. So I do a cold process, and I will also create a video of how I make soap. And so you can choose whichever one you want to use. If you use my method, you will have to buy some of your own materials. You'll have to buy more Crisco, some coconut oil, and your own sodium hydroxide, because it's just a different recipe. But I think the substance, the soap we get out of it is way better. So you make it in lesson 11, and that ends learning set number 2. So in learning set number 3, do substances always come from old substances? I'll be honest with you, this is not a great title for learning set 3. You don't really talk about it a whole lot. I mean, I guess you could, but that's not what it's really about. In lesson 12, you're talking about conservation of mass. And so you do an Alka-Seltzer and water lab to show that even though you do it twice, once where it's an open container so the mass goes down, and then that seems weird, or it doesn't seem weird, it's just like, okay, so I guess mass can change. But then you go back and you say, well, wait a second, what if we control the container and keep the air inside, because we could see bubbles were coming off. And so they say to use a plastic bag. I've never had a good enough Ziploc. Maybe if you got really high quality ones, I always get cheap ones, that they can hold the air in there. But I started using little soda bottles, plastic soda bottles with a screw top on it, and it works great. They really hold the air in there well. I even have the students put the tablets on the scale next to the bottle with the water in it, and they can see the mass. They add the tablets, screw on the top, and they see the mass doesn't change. The whole reaction goes on, no mass change, and then they unscrew the lid and they can see the mass change right away. It just immediately loses a few tenths of a gram. And so you can talk about how the gas does have mass, even though we don't think of gases as having much mass. So that's conservation of mass. That's the key piece there. In lesson 13, we're really talking about, did I make a new substance or not? And this is another big claim, evidence, and reasoning piece. Did this soap, this process that we went through, did we change it from fat and sodium hydroxide to a new substance soap? And what I always like to reiterate with the students is that, here's sodium hydroxide, which is something that will burn your skin horribly. It's just a really nasty chemical. Fat is slimy and gross, and it doesn't wash off with water. And then we create a new substance that can wash off the fat that we made it with. And so the properties have completely changed. So I add those in my properties too, but the lesson 13 is a big one. And it usually takes me a couple days, several days to go through, where I have them test the new substance for solubility, melting point, hardness, all that. And they then compare that to the soap that we initially worked with, and we compare it to the fat that we were working with. And then they write another big claim, evidence, and reason for that question: is my soap a new substance? Or the other one I use is, did I make soap from sodium hydroxide and fat? So those are it's a big one. Lesson 13 takes several days, and you have to wait. One of the reasons why you put in lesson 12 in between there is that it takes a few days for the soap to get to a point where you can actually handle it and use it safely without gloves. And then 14 is, in my opinion, it's kind of an engineering add-on lesson where you can compare your soap to store-bought soap and then ask, well, what can you do to improve your soap? And so, for example, Ivory smells a lot better than the soap we make because there's scent in it. They add a scent, which is a mixture, and you can talk about, well, that's a mixture. You can add color to it so it looks better. There's all kinds of things you can do, but it's just a way for students to be brainstorming some ideas of how they could make the soap better. Again, thinking about it in terms of an engineering design. And that is the end of IC2. How can I make new substances from old substances? And I hope this was helpful. Take care. Bye-bye.